Welcome to the very first virtual lecture for IS 201 this semester. As this is the first virtual lecture, it's probably going to be kind of rough. I'm actually just going to talk through these slides a bit. I've loaded them up with text, not because I think that makes a good slide, but because I'm not going to be there to explain everything. So I figured if I just pack the slides with as much information as possible, you can then use those as a reference. So I hope that's all right. I'm just going to walk through these slides, and then I've sent other instructions along in my email to let you know what else to do to learn. And if any of this isn't making sense, because I'm not there to answer your questions in person, please feel free to take advantage of me during my office hours or email me, and I'm happy to help you make sense of all this. Now, the first part of this is all going to be review, and then the last part will be some new stuff. So I'm going to sort of breeze past the first stuff, and you can pause and slow down and rewind if you need to. Here we go. Let's see what happens. So building models. In database management, we build models. Why? Because models require less cognitive load to understand than all of the data thrown at you at the same time. There's that saying, a picture's worth 1,000 words. Well, it really means it. A picture, in our case, is worth 10 billion pieces of data. So we use models to diagram how our databases are designed and how the entities in our databases are related. So we call this entity relationship diagramming, or ERD, and it is one of the most popular approaches to modeling data. And it shows the entities, the attributes, and all the relationships among those entities. And so I'm going to show you all of those as we go through. So entities, again, this is review. We talked about this in class, but an entity is basically a noun, a person, place, or a thing that has more than one instance. Now, I haven't really talked about instances much. Let's take customer as an example. Customer is an entity that has more than one instance. Why? Because each person, each individual person with their own DNA and social security number is an instance of customer. Each order also has multiple instances. The order that you make at your table or at your cash register is different from the order I make, and each of those is an instance. Now, an entity should also have more than one attribute. Those attributes, of course, are the characteristics of the entities. So a customer will have a first name and a last name and an address and an email address and many, many, many other attributes. So will an order. If an entity you think should be an entity doesn't have more than one attribute, then in fact it is not an entity, it is just an attribute because it is fully described by that single attribute. Now, relationships in databases and in ERDs are drawn with verbs. In this case, we have customer, makes, and order. So this verb explains the relationship. We could also say something like vendor supplies item. So that expresses the relationship. And every entity in our relational diagramming should be related to some other entity. But not all entities have to be related to all entities. Attributes we've talked about. These are the characteristics that describe entities. In this case, we have customer number, name, phone, etc., etc. Again, this is review. Primary keys, we talked about this a lot in class. Just to reiterate a little bit, a primary key is an attribute or set of attributes that might be on a test that can be used to identify uniquely an individual instance of an entity. So the value of the primary key has to be unique for each instance. So what are your primary keys? They'd be something like social security number, your fingerprint, your retinal scan, your net ID, your student ID, things like this that uniquely identify you. Your first name and last name combination would not be a primary key because there might be other people with that first name and last name. Think of John Smith, and there are a lot of those guys. So as we diagram it into an ERD, this is what it would look like, with the entity name at the top of the little table, attributes listed in the table, typically with the primary key listed at the top, the relationship between the two entities here, and then the cardinality. We talked about this in class, and I'm going to focus a little bit more on this just after this slide. But that's how you draw it. So cardinality. Again, we talked about this in class. Bit of review. Cardinality is the maximum number of occurrences of one entity for a single occurrence of a related entity. So one customer can order how many orders? Many. So it's a one-to-many relationship in that direction. One order can be ordered by how many customers? Well, just one. And so we have a one-to-many from customers to order. There we go, one-to-many. Now we could pretend it's one-to-one or many-to-many. If we have many customers ordering the same thing, like if you're co-signing on a large product like a yacht or a house or something like that. Now, when you're trying to figure out cardinality, it's helpful to think something like each instance of entity 1, in this case, that's customer, can relationship, in this case order, at most how many instances of entity 2, orders. So in this case, one customer, so each instance of customer can order at most many orders, one to many. And that's how it works. Each customer can order at most many orders, and each order is ordered by at most one customer. And so this is a one-to-many relationship with the many on the order side. So how would you do the cardinalities on these ones? I know we just did customer and order, but what would you do for order and item? One order has at most how many items? One item can be on at most how many orders? Pause it here, see if you can figure it out. Here's the solution. One solution, it depends actually on how you define item. But in both cases, one solution would be a one-to-many relationship where one customer can order at most many orders. One order can have at most many items. And one item can only be on one order. Now that also depends on how you define the item, which we'll talk about later with serializability and serializing. So mapping an ERD to a schema, when we map entities to an ERD, one thing we have to take into account is where the primary key and foreign key go. Primary key is pretty simple, right? Every entity has its own primary key. But foreign key is a little trickier. When mapping many-to-many relationships, there's a little trick. So we have one student can take at most many courses, and one course can have at most many students. So there's this many-to-many relationship. Where do you put the foreign key? Do you stick it in course or do you stick it in student? Well, with many-to-many, it's kind of confusing. You actually create a new table called student course, typically just the hyphenated names of the two entities. And then for the primary key for this new table, what you need to do is stick both primary keys from the two tables in as primary key / foreign key in this third table, this new table. And then if there are any attributes that are unique to the student course, then you would add those in, such as section number. So the thing to remember here is when you have a many-to-many relationship, neither of those entities receives the primary key as a foreign key in its own table. Instead, you create a new table whose primary key is a composite of the two foreign keys, or I guess in this case, the two primary keys of the other entities. Hope that's clear as mud. Now, when you're mapping non-many-to-many relationships, so one-to-many or one-to-one relationships, what you do is you stick the foreign key in the many side when it's one-to-many, and then in the one-to-one, check to see if there's an optional participation for one of the entities. And if there is, stick that optional, or stick the foreign key in the optional side. So here's an example we can practice with. Who gets the foreign keys? Let's take the customer to order. It's a one-to-many relationship. We just learned that if there's a one-to-many relationship, you stick the foreign key on the many side. So order is going to have a new row here, and it's going to be the customer number as a foreign key. Let's go over here. Same idea. One-to-many. So item is going to have a new row with supplier number as the foreign key. What about here, these two? It's a many-to-many relationship. What do you do here? Well, we just learned that when you have many-to-many relationship, you'll actually create a new relationship table, is what it's called. And the primary key will consist of order number, PKFK, and item number, PKFK. And then anything that the order item would have uniquely attributed to it. There's a thing called table notation. Let's look at this entity back in the previous slide, customer. You can see here in customer we have 3 attributes: customer number, customer name, customer phone. If I go to the next slide, we can break these out into what would look like a table or a spreadsheet. Now there's a way to actually write this out in what's called table notation. The funny thing about table notation is it's actually not a table, it's just a line like this. The way you'd write it is you put the entity name on the far left and then open parentheses, and in those parentheses you put the primary key first, then all the attributes, and then if there are foreign keys you would also stick those in there. So for example, here is the order system table notation. For that big ERD that we saw, here's how you would write out all the table notation. Notice customers, just like we said it, order is going to have the order number as the primary key, order date, and then just like we learned previously, because this is a one-to-many relationship, order is the many side, and so it gets the primary key as a foreign key in its table. Item, let's see right here, it gets its primary key and all of its attributes, and then it also gets the supplier number foreign key because it's a one-to-many relationship. Supplier gets no foreign key. Notice supplier number PK and then its attributes. Same with customer, it gets no foreign key. But the many-to-many relationship here is represented by entity-entity, order item, and then the primary key is the primary keys from the 2 entities that make it up. So order number and item number. That's how you would write the table notation. Will there be a question like this on the test? Most certainly there will be. And will we throw in there a many-to-many relationship? Definitely yes. Will we throw in an optional relationship? Maybe. So I would understand these very well, practice these, and we will practice these in class, so don't worry too much. Let's talk about serializability, last thing. So when you need to keep track of a specific instance of a product, it's called serializable. It has its own ID number. It's transferable. That specific item is transferable. Think of a car. A car has a VIN number. This is a serialized product. Now, most products aren't serialized, like toilet paper and food and most things you would buy at a grocery store. These things are not serialized, and when we list them as items, we don't care which specific bottle of shampoo or which roll of toilet paper you've purchased. It's just a roll of toilet paper or a bottle of shampoo. But if you go buy a car, we care which car you purchased. And so we need to know which specific car it was and what its specific ID number was. And so how does an ERD differ for these types of products? Well, in the case of ordered items, one order can have at most many serialized items. Let's talk about cars. Let's say this is a car. So one order can have at most many cars. I can buy 5 cars at a time if I'm really rich. One car can only belong to at most one order, though. Now this is different from when you have shampoo. If we consider shampoo as a general item, a generic item, we don't care what specific bottle you're buying, you're just buying shampoo. So shampoo can be part of, at most, many orders, and one order can have at most many shampoos. And so it would be a many-to-many. And so that's how it differs for serializable versus non-serializable items. Will there be a question like this on the test? Most likely. I hope this has been useful. Again, if any of this didn't make sense, review the other materials on My Educator and on Learning Suite, and then feel free to talk to me or talk to the TAs to clear up any confusing points. Have a great day!